pH is an important concept in science, but pH values can also affect us directly. Household substances we deal with on a daily basis are acidic, basic, or neutral. The same applies to the food we eat. The aim of this lesson is to bring this concept to life for learners. After completion of this lesson, learners should be able to explain the concept of pH, relate this to everyday life, state whether a solution is acidic, basic, or neutral, compare the acidity of solutions, list some factors that affect the pH of a solution, use universal indicator solution and a color chart to measure pH. Compare universal indicator with cabbage-water solution, list the constraints associated with using an acid-base indicator, follow instructions in order to dilute solutions, collect, organize and interpret data, work collaboratively with other learners, and prepare and use an indicator by extracting a plant pigment.
As you know, acids and bases are the two most important chemicals, right? We need to discover what is the acid and what is the base, and in order for us to discover what's the acid and what's the base, we need to measure the pH value.
The teacher hands out one copy of the worksheet to each group. Group work is more than just a seating arrangement. It encourages learners to work together.
There are 4 questions. On the first page, you need to discuss the 4 questions. Please be prepared to discuss your ideas with the entire class.
Allocating only one handout to each group makes it impossible for learners to work independently.
As a facilitator, how do I encourage participation is, group work is one of them, peer participation, get the kids involved. We just need to be there as facilitators. You need to get them actively involved, give them activity-based things where the kids are totally involved. That's the only way we're going to see whether kids are productive, whether they're understanding, and feedback coming from them.
The learning process is an active process. Learners, we nowadays believe, construct their own knowledge. And in fact, the teacher's role has to change to accommodate the latest theories of learning. Teachers must, in fact, now be seen as facilitators. They make it possible by creating good conditions, perfect, optimum conditions for their learners to construct their own knowledge.
Okay, thank you guys. Your 5 minutes is up, pens down.
The teacher asks the class where they have come across the concept of pH before and to give some examples.
Cheek.
Cheek, very good. What else? True.
Washing detergents and juices.
Very good. Washing detergents and juices. What else, guys? Avinesh?
Toothpaste.
Toothpaste. Soaps. What else? Namrata?
Lotions. Like
Lotion.
Johnson & Johnson, pH 5.5.
5.5, very good. Johnson & Johnson's. Now, these are all examples where we come across pH. We come across pH at home, media, at school. Simple examples, chick, shampoo, washing powder, juices, lemon juices, yogurt, fruit, all the fruit that you eat. Some of them is acidic, and there's certain things that are basic. So we need to see what are basic and what certain substances that are basic and certain substances that are acidic. So in order for us to see this, we need to measure the pH value of a certain solution. So our entire lesson for today is going to be based on measuring the pH value of certain solutions, right? Let's move on to
the next question on the worksheet is, what is the meaning of pH?
What does the term mean? Who can tell me? Milan?
I would think it's a quantity that determines acidity or alkalinity of a substance.
Very good, Milan. It normally tells us the alkalinity or acidity of a certain substance or a certain solution. What else can you contribute from the term pH? Namrata?
It's a scale which ranges from 0 to 14.
Right, it has a scale. The scale ranges from numbers 0 to 14.
The scale values of 0 to 14 are in fact incomplete. Although 0 to 14 is the range of common use, pH values can also go below and above this range.
Now, I need to know from you, what else does pH tell you? What comes to mind?
Greater than 7 would be acidic and less than 7 would be basic.
Very good. Right. pH more than 7. pH more than 7 would be basic. pH less than 7? Acidic, very good. So that ranges in our scale, do you understand? So we have a certain scale. It ranges from 0 to 14, right? 7, this point here, on 7. 7 says what? Who can tell me? 7 says that a substance or a solution is what? Neutral. Right, on my right-hand side, more than 7. What does more than 7 tell me?
Basic.
Who can tell me what does less than 7 mean? A substance is acidic, very good. If I ask you what is the difference between the pH, pH 3 and pH 4?
pH 4 is less acidic than pH 3.
Very good. pH 4 is less acidic compared to pH 3. pH 3 is more acidic. Do you understand? It's more concentrated. Right. We're going to complete the activity now on measuring pH. The reader of each group, please read out what you require, your chemicals that you require, and your apparatus that you require. And the chemicals manager, please go and collect your chemicals. Your chemicals are over there, and your apparatus is over there.
Learners from each group collect the materials required for the experiment of measuring pH using a universal indicator.
Please be careful. You have acids and you have different chemicals. If instruction says 10 drops, make sure you use 10 and not 11. Right? If you do make a mistake, use your pipette, suck up all the liquid, use a paper towel to clean your well, and you can start the activity again.
Each group now starts the experiment by following the instructions on their worksheet.
How to prepare wells A7 and B7.
They've been asked to test the pH of 7 different solutions in their combo plates using a universal indicator.
Labeled indic to add 1 drop of universal indicator solution to each of the wells A1 to A7.
The teacher can use the colors of the solutions in the combo plate wells to assess the practical work of each group. If the instructions have been carried out meticulously, all colors on the color chart should be seen in the wells in row A of the combo plate.
The microscience kit actually gives you an opportunity for learners to work. It gives them an opportunity to do things on their own, to conduct experiments on their own. The physics as well as chemistry, they are given a chance to do things on their own, besides sitting back where the teacher would do every single thing for them.
A5 is light green, and A3 is orange, A4 is green, A7 is light blue.
She's asked the learners to assign roles to different people in their group. In other words, by doing that, she's acknowledging that each person in the group is going to do some specific task for the benefit of everybody in the group. In other words, they're all going to work together to achieve a goal. It's a common goal.
Right, guys, you completed your activity. Now we're moving on. Let's discuss our questions. The first question. Does the pH of a solution depend on the volume of a solution?
If you have a drum of water and a teaspoon of water and you add an indicator, the pH levels still remain the same.
Right, as you know, a given solution would have the same pH, whether you test a teaspoonful or a cupful. When we're looking at our wells, from wells A1 to A7, which is the most acidic?
A1.
Right, which is your least acidic solution in your combo plate? A7 and? Very good. A7 and B7. Who can tell me what is the pH of distilled water?
Distilled water is neutral, so it's 7.
What factors do you think the pH of a solution depends on?
The concentration of the liquid.
Firstly, nature of the substance of a solution and concentration of a solution. This is my own acid-base indicator that I use. We used a cabbage, we boiled the cabbage, I drained the water, and this is the water that I use. So for our next activity, you go.
The learners are now asked to repeat the earlier experiment, this time using the cabbage-water acid-base indicator.
There are various reasons why practical work is very beneficial to learners. Practical work teaches learners lots and lots of other skills. It teaches them to follow written instructions accurately. It teaches them to observe. It teaches them to solve problems. For example, if something doesn't work, they've got to work out a strategy in order to solve that problem.
How can you work out the pH of a solution in wells in row B?
We already know the results of row A, so we can use that to compare to row B.
Learners are able to compare the colors of the wells in row A, which were tested with universal indicator, with those in row B tested with cabbage-water indicator. In the next activity, learners will use the skills they've already acquired to test the pH of common everyday substances with universal or cabbage-water indicators.
Shampoo, household products, those were easy access and things that the kids knew, they saw every single day, they come into contact every single day. It's better if they're familiar with things and they're more comfortable and they recognize. They need to see and recognize and be able to know what they're working with. Right, after you completed your activity, you can come to the board now and record your observation. Right, group 1.
To save time, the teacher has allocated different solutions to each group. The use of everyday substances in their packaging has great appeal to learners. Testing these is much more relevant to them than, for instance, measuring the pH of ammonium chloride, and it is a very good way of integrating the world of science into the daily lives of learners.
Right, okay class, what do you notice? Which pH measurement surprised you? What you notice on the board, you got substance tested, indicator used, you used 2 different indicators. You used a cabbage juice indicator and a universal indicator. But what did you notice?
The Coke, we never know it was so acidic.
Okay, and what else?
That's it. The tomato sauce and the cough mixture we couldn't find.
Why? Why couldn't you tell the pH measurement of tomato sauce and cough syrup?
The color deceived us. We couldn't differentiate between the color of the tomato sauce and the color of the indicator.
Very good. You couldn't distinguish between the color of the indicator and the color of the substance. When it's difficult to measure the pH of a certain substance, we use a pH meter. The pH meter consists of electrode, a glass electrode, here's it here, which is absolutely delicate, very, very delicate. When it's not in use, it needs to be in potassium chloride. Right? Right, this is my voltmeter, and from this here, I would get a reading.
The teacher asks the groups to bring forward substances that they were not able to test using the universal indicator. By allowing learners to use the equipment under her supervision, the teacher is maximizing learner input into the demonstration.
We leave it for a few seconds until the reading settles or stabilizes to get an accurate reading.
Okay, the pH reading is 3.86.
3.86,
yeah.
Right? We're going to put that down on the board. Put it down on the board. Right, what do you notice here, class? What do you notice about our reading? Where for Coke we had 1 to 3, right? We had 1 to 3. That was our indicator that we used, and now we had a meter reading, 2,51. That is 2 decimal places, so we had a much accurate reading from our meter. Right, what can you discover? What did we conclude from this lesson today? Who can tell me?
What we learned is we learned all about pHs and how different substances have different pH readings with different indicators.
Yes. Those were our common indicators that we could use in the lab, right? Who can give me another example of an indicator very quickly?
Tea.
A very good example that we find at home. A common example, if we add a little lemon juice to tea. Who can tell me on hand what would happen if we add a little lemon juice to tea? What would happen to the color of the tea?
It turns yellow.
Okay, it doesn't turn yellow. It actually, the tea becomes lighter. It's black tea that we use as an indicator, and the black tea would become slightly lighter.
Once she's done the practical, and she herself has made all these observations, and then every year she does the experiment with the learners, she will see more and more different things in it. And so her experience will grow, and she will facilitate learners learning more and more effectively.
Now that we've seen the video, it's time for us to welcome our guests in the studio. We've got Feroza Esop from Northview High School. We've got Kanye Zwane from the Science Education Project and Marissa Rolnick from the Wits School of Science Education. Thank you for joining us. Let me start with you, Marissa. Why is the teaching of the topic of pH important?
Well, it's part of the whole teaching of acids and bases, and there are a lot of reasons. It makes use of a lot of concepts which have come from before. It's also something which learners need to relate. Chemistry is about explaining what you see at the macro level. That's at the level where you can look at things with your eye by using theories about atoms and molecules at the micro level. And there are a lot of opportunities to do this in acids and bases. That's the one reason. The other reason is that there are a lot of opportunities to relate it to everyday life, which are it's very important that science should be seen as part of everyday life. And the third thing is there's a lot of opportunity to do activities.
Okay, can you add to that?
Yeah, I would say many of the topics that follow on need the learners to know acids, or this particular compound is acidic, this one is basic. So it sort of lays a foundation for other subsequent lessons.
Okay, Feroza?
You can relate pH to everyday relevant life. I mean, everything, whether it be your blood or what you eat or what you drink, you know, you need to know about the pH of substances. And so, as Marissa said, you know, to take it from a micro level to a macro level where it actually becomes relevant and people can see.
And why do you think it's of value to introduce learners to a variety of indicators?
Well, you know, I mean, learners are used to seeing the same old, you know, a litmus or bromothymol blue or methyl orange, and they need to be made aware that those are not the only kind of indicators you get, and what actually is an indicator, that it's simply a dye, you know, and so you can actually make your own indicator. So I think to make them aware that, you know, you don't just have, it's not just limited to the ones that they normally use in the classroom or in the lab.
Okay, can you?
Yeah, also that the dye is a natural pigment, like she brought the cabbage, which contains a dye. So those that we use normally in bottles have in one way or the other been developed from the natural dyes.
Okay. Marissa?
The other thing about indicators is that they change colours at different pHs. So if you use a lot of different indicators, you can, if you've got the thing set up with the universal indicators, you can see, for example, that something like phenolphthalein, which incidentally is also used as a purgative, changes pH at a very alkaline level, whereas you get something like bromothymol blue, which changes pH at pH 7. And then they can see that the universal indicator is actually made up of a mixture of lots of different dyes that change at different places, and that's why you can see the colour changes.
Okay. Kanye, how effectively do you think the teacher managed the class?
I can comment on the management of the practical work, that I think she did very well. She had the chemicals and the kit, the micro kit, available and had them take them in some particular order, you know, and then she had some instructions for each member of the group. Although one cannot really comment on the inter-relationship between the groups because we didn't see much of that in the video. Yeah.
Okay. Rosa, can you add to that?
She seemed to manage reasonably well, although I do feel that perhaps she had been through this before. It seems what we saw was, you know, a reasonably well-managed lesson. I mean, the kids seemed to be listening and interested, and she was quite well prepared.
Marissa?
Well, I think one thing we must realise is teacher's very lucky that she doesn't have a very big class. So that makes things a lot easier to organise. I think a lot of teachers aren't so lucky. Kanye commented on the practical. I'd like to comment on the whole class questioning. I think there it becomes clear that, in fact, the learners were perhaps repeating a lesson that they had been taught before. So it was very difficult to see perhaps how the teacher was managing the interactions with the class, and we were not allowed in the video because of the editing to see enough of what she was doing with the groups. But she's clearly somebody who's experienced. You can see that in the way that she's got the groups organised, they're group leaders, they know when they've got to go and get the equipment, and as Kanye said, the materials were all ready and laid out, and she was clearly prepared for the lesson.
And what you've just said about questioning there leads me to my next question. The teacher made a lot of use of whole class questioning. Now, was this the best option for what she was trying to achieve?
The problem about the whole class questioning, I think, was, as I say, it seems like they'd been through this before. And it would have been nice to see her teach them something they hadn't done before, because then you can see what she does maybe with a wrong answer. You only had one example, I think, right towards the end of an answer that she wasn't that happy with, whether she would redirect the question to another learner, whether she would follow that with another question, or whether she should simply tell the learner the answer. You know, I'd be in favour of either redirecting the question if she didn't get something right, which she did do. I think she tried to actually ask another question to see if she could get something better. And the other thing is the sort of level of the questions that are asked. And maybe I can hand over that to Kanye.
To Kanye, can you add to that?
Just to that, she was mainly asking direct questions for them at the end of her phase. You remember she had part activities to get feedback from them, and then they would give them feedback of that particular section. So it wasn't questions that are building up to some knowledge. It was just consolidation questions, you know, like straightforward instruction. Then from that point, they will move over to the next activity.
Okay.
Yeah.
Feroza?
You know, I feel it says whole class questioning. I think it would have been a good idea had the learners been able to ask their questions, you know, things that they were interested in. I think, you know, give them an opportunity to show, you know, their difficulties or their interests. And I didn't see any opportunity for that at all, you know, where the pupils actually were allowed to ask or to, you know, to take an issue forward. I think that would have been nice.
Should have gone both ways.
Yeah.
Okay. Any other issues you'd like to raise? Kanye, starting with you.
It was supposed to be grade 11, right? Because when we were watching, we were asking, this is a grade 7 lesson. We're looking at the age of the learners, they are grade 11, you know. But well, maybe one would say the aim was to do the practical, in which case the theory could have been developed to be just pre-knowledge. Because the way that the pH, for example, was defined, it's a secondary level, junior secondary level definition. Whereas at this grade, they are doing more pH in terms of hydrogen ion concentration in the substance and the like, you know. So that was not really quite well done.
Okay.
Yeah.
Marissa?
Now, I think I must agree with Kanye that the content, the level, that there wasn't much you could see in the video regarding conceptual understanding of the acids. There was a very superficial explanation given of pH. The micro level that I referred to earlier was not talked about at all. Now, in grade 11, learners learn about acids as hydrogen ion, as proton donors, things which produce hydrogen ions in solution. And they define bases as hydrogen ion acceptors, or things which accept protons in solution. And it is very, very important at the FET level that the learners in every topic in chemistry get down to the atomic and molecular level to try and explain things. Furthermore, there's another level in chemistry. There's the macro level, there's the micro level, and there's also what we call the symbolic level. Now, at the symbolic level, that is writing equations and things like that. And in the case of pH, it would be understanding pH as minus the log of the hydrogen ion concentration, which is, I think, a concept that is handled in the FET level. And once you realize that, and you link it to the mathematical understanding of logs, then you start understanding that a solution of pH 2 is 10 times stronger, or more concentrated, I'm using the wrong word, is 10 times more concentrated than a solution of pH 3. And yet, if you simply teach it as a scale from 0 to 14, then they will start thinking that maybe a solution of pH 4 is twice as concentrated as a solution of pH 2, which is not the case.
Okay.
The pH is a logarithmic scale.
Okay. Feroza?
Yeah, I think perhaps there was an opportunity for her to clear up a big misconception that learners have between strong and concentrated, weak and dilute. I think there was excellent opportunity, you know, in that lesson for her to bring that across to learners, which I didn't see her do. And I think it's actually very important to make learners see the difference between something which is strong and something which is concentrated. And I think she could have done that.
Okay. Well, that's how we come to the end of this session. Thank you very much for joining us, our guests, Feroza, Kanye and Marissa. And to our viewers at home and at schools, thank you very much for joining us. Do join us again soon. Goodbye.